Sorry, Lydia, we were not recording. I'm sure she's going to watch this. Sometimes I have to say I know you're not going to watch it, but Lydia will watch it. All right. 1 minus 2/3 plus 1/5. All of this over here is 0. So if we get common denominators, we got 15 over 15 minus 10 over 15 plus 3 over 15. And that is going to give us 8 over 15. So whatever your units are for this, if it were feet, if it were miles, if it were inches, it's going to be 8 over 15 cubic feet or cubic inches or cubic miles, whatever you're looking at there. It does seem, which it is only going, so whatever this is only like, let's say it's feet, it's only one, your area is like 1 foot wide and 1 foot tall, but this part's cut off right here. So if you think about it, like if this was just a square, if we just had a base of a square, what would the volume of that be? It'd be 1, right? Because it'd be 1 times 1 times 1. So you would expect your answer for this to be smaller than 1 because you're not using that corner right there. All right, this would fit in a box that was 1 by 1 by 1. For that. All right, next one. All right, we got all right, so notice that one had cross sections perpendicular to the x-axis. This one has cross sections perpendicular. Ooh, that is not the highlighter. Perpendicular to the y-axis. Okay, so this means instead of our cross sections going, vertically like they did this time, they're going to be horizontal. If you have a problem where it's perpendicular to the y-axis, you have to do it in terms of y, right? So your equations need to be in terms of y. You'll be looking at everything in terms of y. So we have, for this, I won't be able to use the program for this one because it does not do these in terms of y. We've got y equals 1 over x, y equals 1, y equals 4, and x equals 0. So let's sketch this. Let's do the horizontal lines first. I think it's going to be first quadrant because you got y equals 1 and y equals 4. So we got 1, 2, 3, 4. And we have a horizontal line at y equals 1. We have a horizontal line at y equals 4. We have x equals 0, which is just our y-axis right there. And then the more difficult one to graph right here is y equals 1 over x. I would just plug in some numbers. I'd make myself a table for this. If you plug in 0, what are you going to get? Undefined. It doesn't help you. You can't graph that. If we plug in 1, we would get 1. So we would have the point 1. Mark this. Not right there. All right, we'd have the point 1, 1 would be right here. Oh, I should have made this. Actually, let's do this. To be able to draw on this a little better, I'm going to put 1 way over here. Because I'm getting the point 1, 1, which is going to be right here. And if you think about what this graph should look like if I start plugging in other numbers, if I do 2, I get 1/2. If I do 3, I get 1/3. If I do 4, I get 1/4. So this is just like getting smaller and smaller and smaller here with a horizontal asymptote. That doesn't even really matter because we're already out of the section that we need to look at. This part right here is going to look like this, and it's going to have vertical asymptote. So we are looking at a base here. Like this. And this time, our squares are not going to be vertical. They're going to be horizontal for this. So we would be doing, let me pick a color, use orange here. We're picking, like let's say I'm going to draw in one of our ours that we're using here, this is orange, we would be going across right here, and then we'd be like building a square that pops up off of the graph like that. So this would be our S. So since that is a horizontal line right there, I've got to think furthest right minus the furthest left for that one. Now, we are still using squares, right? I think. No, oh, rectangular. Okay, so our height, our cross section is a rectangle with height equals 3. So actually, well, this is okay, like I've got it drawn. We can still call that bottom side S right there. What's the height of that rectangle right there? It is 3, right? So whatever this shape does, it's going to have a flat roof, right? Because every rectangle has the same height, right? So when we make this, like our sides are going to have these curved sides, but the top is going to be flat because the height of all the rectangles is the same. That didn't happen with the squares because whenever our square had a short base, it also had a short height, right? And it kind of got bigger and then smaller. Let me even see if this over here will do. This one won't even do rectangles here, so I can't even show you what it would look like. But it's basically going to be like a, it's going to be almost flat, but it's going to have this weird sort of cutout on the side there. So my area for a cross section here then needs to be, how do we find the area of a rectangle? Length times width, or we could call it base times height, which might be a little better this time since we're kind of making our rectangle up and down. So it would be base times height. What did we say the height was going to be? 3. So we got the base times 3. In fact, let me label this B over here. Here's our base is B, and our height is 3. So B, right here, that is going to be the furthest right minus the furthest left, but it needs to be in terms of Y. Is that black equation right there in terms of Y? It is not. So we got to solve it for Y, for X. So we got Y equals 1 over X. To solve that for the X, we'd multiply both sides by X. So we'd get X, Y equals 1. Then what would we do? Divide by Y. Basically, your X and Y is just trade places. So X equals 1 over Y. So B would be 1 over Y, which is this point right here, minus the point over here. That boundary is just on the vertical y-axis there. What's the value there? What is your x value there? 0. So minus 0. You'll notice if it goes all the way to the line, you don't have to put anything there. So B just equals 1 over y. We need to put that over here in our equation. Oh, and I should not have used the x right here. I should have used the y. So a of y will equal 1 over y times 3. Or, if you want, you can make that, well, actually I might leave it like that. I think I like it that way better. You could do 3 over y if you wanted. So, we would need to integrate our formula for our area, which I'm going to write as 3 times 1 over y dy. And what do my limits need to be here? It's not 0 to 1. Because this is a dy, so we don't look at the x-axis. 1 to 4. 1 to 4. It is a length of 3, but you're looking at your value, so it's 1 up to 4. That's what we use there. Okay. So whenever we're doing it in terms of y, we have to look at the y-axis for our limits. So we're looking at the lowest and highest on the y-axis, not the x-axis, which is a really common mistake. The 3, really, we could just like pull it out front, right? What is the integral of 1 over y? Natural log. So we're going to get 3 natural log of the absolute value of y, and we're going to evaluate that from 1 to 4. So we got 3 natural log of 4 minus 3 natural log of 1. Now, probably not going to leave the answer like that, because what is the natural log of 1? Is 0. So they might say 3 natural log of 4. Sometimes they are cruel. No. You're thinking in the right direction, but they wouldn't. You could do that, but they won't do it that way. They'll break it down further. How can I write 4? I could write 4 as 2 squared. What can I do with that exponent? Bring it out here. So they might do 6 natural log of 2. It just to make you.
What if they did natural log of 64?
Yeah, like if you had natural log of 64, they might not leave it like that. They might do. That would be. I mean, they could do 8 squared. Pull the 2 out. There and do 2 natural log of 8. But it's also 4 to the 3rd, right?
Yeah.
So they could also do natural log of 4 to the 3rd. Oh, no, it's 2. No, it's 2 to the... Because 4 will break down again, right? Then you'd have 3 natural log of 4. But 4 would break it down again. 3 natural log of 2 squared. 6 natural log of 2. Yeah. So... Yeah. And it equals 3 natural log of 4. And natural log of 64. They're all equal to each other. Any of those answers would be accepted. Now, if it is on a free response, you can leave it here even with that natural log of 1. Because you don't have to evaluate. So on free response, stop here. The only reason you would need to do this right here is if you got this and your answer choice wasn't there. Which I have seen release questions where they did that. So I'm warning you that the evil geniuses that work for AP might do something like that to you. But we've got to outsmart the evil geniuses.
And then you could take 2 because it has an exponent of 1 and bring that out from 6 natural log of 2. Yeah.
Yeah. But it wouldn't really change anything. All right. So, depending on what your answer needs to be left like, you could leave it here, you could leave it here. Any variety of these right here will also work, on a free response, there's no need to go past this. All right, find the volume of a solid with a semicircular base of radius 5, whose cross sections perpendicular to the base are parallel to the diameter and are squares. So they have given us a lot of information and no formula anywhere, no equation anywhere. So I know I have a semicircular base. I'm not having time to do this problem, am I? All right. Let's look at the homework and see what you can do. You guys are full of outrage today. Full of outrage. All right, let's see what it was supposed to be. Oh, shoot. It's a worksheet that I didn't print. You still got to do it. You still got to do it. Let me see if you got to do all of them. Because obviously if there's a semicircle one, you're not going to have to do it. That one's okay. That one's okay. That one's okay. These are okay. Because there's not a semicircle one. We need to do one because they might give you one. But I can run copies of this if you need me to. Or you can do it from Canvas. So if you need a copy, let me know. And I'll have it for you during fourth period or EHS time if you're in here. Or you can just look at Canvas and do it from there. Whichever you prefer to do. But 1 through 4, there. On those, I want you to sketch a graph. Preferably from your head, but if you can't do it in your head, go type it into Desmos to get a picture of what it looks like for those. So sketch a graph and then try to work it out. Okay? So I want to see those graphs, and if all you've done is recopied the problem like some of you guys did last night, I will not give you credit. Try something. Yeah.
Jeremy, so the GAC, it's the Aquatic Center in Greensboro.
Oh, wonder if that does look like it, sort of, doesn't it? It's
I don't have any good pictures of it, but it kind of looks like a whale.
yeah,
It's pretty neat.
I gotta think about that. All right, that was the GAC. Greensboro Aquatic Center. I'm gonna see.
Look like your worksheet.
Okay, you're in my EHS time, right?
Yep, I am now.
Yes. So I'll get it for you.